Hello, welcome to video 8.3.2 where we're going to talk about ionic radius. So for ionic radius, again, we're going to start with one of these charts, just like we did before, talking about trends on a period and a family. So the first thing I'd like you to do is pause the video and fill in this chart. Go ahead and do that now. Okay, welcome back. So chlorine here, our electron configuration is neon. And then this is 3s2, 3p5. Now chloride, which is the negative electron, adding an electron there, so that is an anion. That means you're going to have one more electron. So it's going to be the same thing, but the addition of one electron. So 3s2, 3p6. So from 5 to 6. Okay, so for potassium, our electron configuration is argon, and then 4s1. Now K plus means you've lost this electron. Now important to note here, don't just simply take this away and write argon, because it's not going to tell you anything about where the electrons are located, and you're going to want to see that. So instead, this is going to be neon, 3s2, 3p6, which is the electron configuration of argon, but again, this should be expanded out so you can see it. Okay, the number of protons, chlorine has 17, and it's got 17 electrons, it's neutral. Chloride still has 17 protons, but now it's got 18 electrons. Potassium has 19 protons, 19 electrons. It is electrically neutral. And the potassium ion, K plus, is 19, and we have 18 electrons. It's lost an electron there. Notice the radius is given to you here as well. So chlorine is 79, but chloride is 167. Potassium is 243, but the potassium ion, K plus, is 152. Okay, so now that we see that, let's go ahead and see if we can explain these differences. So for number 7, part A, explain the difference in the radius for each pair, potassium versus chlorine. So which one is larger? So if we just compare, well, potassium is larger than chlorine. It's got a bigger number. So potassium has a larger radius than chlorine. Why? Please go ahead and pause the video and think about why, and then come back and check your work. Okay, so this one actually turns out it's not too, it's pretty intuitive. So the outer electron in potassium here is in the 4s subshell, and the outer electron of chlorine is in the 3s, and the 3p orbital. So 4 is farther away and bigger than 3. So that means the electrons, the outer electrons in the 4s are less attracted to and therefore further away from the nucleus. And just generally, as you get farther out, the more and more shells you have, generally, the larger the atom. So the outer electron in potassium is in the 4s orbital, while the outer electron of chlorine is in the 3p orbital. And the outer electrons in the 4s are less attracted to and further from the nucleus. So the outer electron in 4s are less attracted to and farther away from the nucleus. Okay, and so that is why potassium is bigger. So now let's start comparing ions. So now we have chlorine versus chloride. Well, which one's bigger? Let's go ahead and take a look. So chloride, turns out, is a whole lot bigger than chlorine. So chloride, so Cl minus, has a larger radius than chlorine. Why? So please pause the video, think about this, and come back. Okay, so welcome back. So for this one, I'd like to show you actually like a little example with some of my paper clips here. So I'm going to pretend each one of these is an electron. So my chlorine the Cl with just no charge, right, has 17 electrons. Chloride has 18 electrons. That means we're looking at a difference of 1 electron. So if this has, let's see, this is 3p5. 3s2, 3p5. So let's just look at just the 3p5. So if we have some electrons here, no, let's add the s ones too. Okay, and they're in a circle, right? They're all wanting to get as far away from each other as they possibly can, so they're all equidistant there. So we have 1, 2, 3, 4, 5, 6, 7. So 2 plus 5 up here, 7. That's where I'm getting this number. Now, if I want to make chloride, I'm going to need to add an electron. Now remember, all electrons are negatively charged. So if I pull this electron in here, if I push this electron in, well, now all of a sudden we have a ton of repulsion here. And what's going to start to happen? Well, these are going to want to get away from that new electron. And look what happens to all the rest of them. They all need to spread out, and they all need to start to get away to achieve that maximum separation there. So if you added an electron in, you created more room because these all started repelling each other more. And when they repel, they went from smaller to bigger. They take up more space the more they repel. So that's, in general, in a nutshell, the reason. So both chlorine and chloride then have 17 protons, so that really doesn't have anything to do with it. But while chlorine has 17 electrons, chloride has 18. So let's write that down. So while chlorine has 17 electrons, chloride has 18 electrons. More electrons in a subshell results in greater electron-electron repulsion. And overall, that increases the size of the atom. So increasing the size of the atom. Okay, so now let's take a look at potassium versus the potassium ion. So which one has a larger radius here? So if we look at potassium, 243, and the potassium ion, missing an electron, 152. So which one is bigger? Well, that's going to be potassium. It has a larger radius than K+. Why? So I want you to think about this, pause the video, and then come back and check your work. Okay, so both potassium and the potassium ion have 19 protons, so those are the same. But the outer electron of potassium here is in the 4s orbital. So right here, the outer electron is in the 4s orbital. However, when you take away that electron to form the potassium ion, that positive cation there, you have lost an entire shell. So now instead of having a level 4, like the 4th shell out, now you only have 3 shells. So now you only go 1, 2, 3. So that is like saying if you had, let's see, so I'll show you on here. So here's your nucleus right in the middle. You have 1, 2, 3, 4 shells, making the atom quite large. If you completely lose the electron in that 4th shell, all of a sudden now you only have these 1, 2, 3 shells, and the whole atom shrinks. So, while the outer electron, of potassium is in the 4s orbital, the outer electron of the potassium ion is in the 3p orbital. Outer electrons in 4s are less attracted to and farther from the nucleus, resulting in a bigger atom. Okay, now let's talk about part D. So we're going to compare the potassium ion K+ versus chloride. So let's go ahead and take a look at those radiuses, or those radii rather. So chloride is 167, potassium is 152. So chloride is larger. So I guess the question there would be, why? So why is chloride larger than K+? Please pause the video, think about it, come back and check your work. Okay, so for this one, it's interesting because both have the same number of electrons. So both Cl- and K+ have the same number of electrons. And that's 18 in this case, I believe. Yes. Okay, but while chloride has 17 protons, K+ has 19 protons. So while chloride has 17 protons, potassium has 19. So that means we're going to have a more positive charge in the nucleus of potassium. Because of that, the electrons are going to be more attracted to the nucleus of potassium than chloride, and therefore this is going to be smaller because those electrons are feeling that attraction and being pulled in closer to the nucleus. So the outer electrons are less attracted to chloride, and therefore farther from the nucleus with fewer protons. So we call these isoelectronic species. And we call them isoelectronic species because they have the same number of electrons, but they have different charges and they have different identities too. So these are isoelectronic species. And for any isoelectronic species like this, where the number of electrons is the same, the only thing that's really going to affect the size or determine the size is the nuclear charge. So for isoelectronic species, the nuclear charge determines the size. So let's go ahead and write that definition here on the bottom so we have it. So isoelectronic species. These are species that have the same electron configuration. That means they have the same number of electrons. Okay, so that is it for video 8.3.2. See you soon for video 8.3.3.